everybody. Today we are discussing exponents. We're actually revising exponents and doing some exercises together. And as I have promised many times, we establish a link between Russian curriculum and American curriculum. Okay, what we do first is to look at our textbook. And we revise operation with exponents. First of all, let us remember that an exponent is just a short way to write down actually multiple products, like, for example, 3 to the power of 4 is 3 multiplied by itself 4 times. Remember that we call 3 a base and 4 an exponent. We can, of course, calculate this product, but what we would be interested in is this form, 3 to the power of 4. And let us remember that any number to the 0 power, for example, here it's 5 to the power of 0, it's 1. So 3 to the power of 0, it's also 1, and so on. And of course, 5 to the power of 1 is 5, so any number to the power of 1 is just the number itself. So this example is good. 5 to the power of 20 actually means this huge number, which I can't even read. It's something like Google. Anyway, it's much easier to write 5 to the power of 20 than this number. And what is more important, it's much easier to handle it. Our next step is to revise multiplication of numbers with the same base. When we write 3 to the power of 4 multiplied by 3 to the power of 4, we can actually write down what it means, and it means that we should take 3 repeated 4 times and multiply it by another bunch of 3's, which is repeated 4 times also. And if you calculate how many 3's are there in our products, we find that there are 8 of them. So we see that 3 to the power of 4 multiplied by 3 to the power of 4 is 3 to the power of 8. And the rule is that when we multiply two exponents with the same base, we just add the exponents and keep the base the same. So for example, in this example, y to the power of 7 multiplied by y to the power of 4 is just y to the power of 7 plus 4, which gives us 11. Here we see that if we can only do that if the base is the same. We can't, for example, do this. So it goes only for the same base. The next step is to revise division numbers with the same base. And when we divide, we actually, the rule is here, we just this expression x to the power of a over x to the power of b, we get as a result x to the power of a minus b. And so the power here in the denominator, it actually gives us a negative power, and we just have to find the difference. Our next step is a power to a power. When we actually, that's maybe the most difficult one. When we have this object 2 to the power of 3, and then we put it to the power of 2, so consecutive powers. We just have 2 to the power of 3 repeated 2 times, and we can again calculate how many, just count how many 2's there are, and we find 6. How do we get 6 from 3 and 2? It's a product, it's 3 by 2. So in letters we just keep the base, in this case it's G, and we multiply the exponents. 4 by 3, it's 12. So that's the general rule. And now exercises, and let us first write down general rules we've just revised. So the first one is, those are the rules. The first one is that a to the power of 0, any a, is just 1. A to the power of 1 is just a. And the second one, a to the power of x multiplied by a to the power of y gives us the same base, a to the power of its sum, the sum of the exponents. Then division, when we have this thing, a to the power of x over a to the power of y, we have to keep the same base, and we find the difference. We subtract the power which is in the denominator from the power which is in the numerator. And from here, from 1 and 3, we can say, and we can see that if we have the same powers in the numerator and denominator, the same exponents, then formally from this rule, from this last rule, we get the base x minus x, which gives us a to the power of 0, which gives us exactly 1. It's absolutely natural because we can see that just a to the power of x cancels, which is in the numerator. It cancels with the a to the power of x, which is in the denominator. Then multiple powers exponents. If we have a to the power of x and we want to repeat it y times, so consecutive exponents, we just say have the same base and we multiply. And then the thing which we didn't discuss, but it follows from what we've just written, when we have a product a multiplied by b to the power of n for a change, this will be a to the power of n multiplied by b to the power of n. For example, let us see an example to this. If I have 5 multiplied by 2 and I want to put 3 as its exponent, and I can say that it's 5 to the power of 3 multiplied by 2 to the power of 3. But on the other hand, I have this thing. I can perform the multiplication in the parentheses and get 10 to the power of 3. So actually, I can see that I can do this, it's a kind of factorization. Actually, it is 10 to the power of 3 equals to 5 to the power of 3 multiplied by 2 to the power of 3. Well, let us perform some exercises. Let us actually work here. It will be the same. So, some exercises. First, I will take them from perform the following operations, leaving your answer as a number to a power. Remember that the parentheses can mean multiply as well. There is no multiplication sign. I put a dot like in Russian school. There is a cross like also in Russian school everywhere. Okay, so we have, let us perform this. So, according to the rules above, we just keep the same base, and we have to add the exponents. So we have to find the sum of 3 and 7. So I won't write 3 plus 7, just 5 to the power of 10. As for the next one, number 2, we understand that the second object is 12 to the power of 0. It gives us 1, whatever the base is, and in this case it's just 12, but it could be anything. So what we have here, we have 12 to the power of 9 multiplied by 1. Or we can say 12 to the power of 9 plus 0. Anyway, it gives us, in any case, 12 to the power of 9. This, we have our first algebraic problem, and the letter is t. And what we have here, we have to keep the same base. It's fortunately always the same in the numerator and in the denominator. Then we have to add all the exponents which are in the numerator. So we have 5 plus 4, and we have to subtract all the exponents which are in the denominator. So it's minus 2, which gives me t to the power of 5 plus 4. It's 9 minus 2, it's 7. That's the result, t to the power of 7. Here, again, a numerical problem, and we have the base of 4. We have to add everything in the numerator, 13 plus 10, and subtract everything in the denominator, which gives 4 to the power of 13 plus 10, it's 23, minus 7, it's 23 minus 3 gives 20, and minus 4, it's 4 to the power of 16. Here, again, letter problem, and I do the same. I keep the base, it's fortunately the only one, and I have 5, it comes from the numerator, and have to subtract 1, which comes from denominator. Maybe the complexity of this problem is that we have to determine that in the denominator we have 1 power of 1, which gives me finally f to the power of 4. There we have the base u, and it gives me 11. Yeah, I have to subtract 4, and it gives me, God forbid, u to the power of 7. Here, consecutive powers, exponents, and I have to keep the base 5. And remember that this time I don't add, I multiply. 4 multiplied by 5, 4 multiplied by 5, which gives me 5 to the power of 20. Here is the most complicated problem. First, I have to open the parentheses in both cases, and b to the power of 3 and then again to the power of 6 gives me the first b. It's 3 times 6, it's 18. And this one I keep, sign, multiplication sign. b becomes 2 times 9. It's again 18. And now I have to add everything which is in the numerator, and there is only a numerator. We can always say in this case the denominator is 1. 18 plus 18, which gives me b to the power of 36. And the last one is j to the power 11, and again to the power of 5. We know that we have to multiply. Oh, this time I'll have to move myself 2 to the power, unsuccessfully, 2 to the power of 11 times 5, and it gives me j to the power of 55. Very well, now let us have a look at Russian problems. To do that, we take a 7th grade book. This topic is discussed in the 7th grade and in the 8th. Here are 6.24, you see simple problems. And we have a very simple thing. The task is the same. What difference do we have here? The only difference which we have here, the first one is familiar to us. The first one is absolutely familiar to us. We have a base of 2. We have 2 to the power of 4. You see the multiplication sign is mainly a dot, but it's the same. I can rewrite it in American style. I wouldn't call it an American style. 2 to the power of 4, which gives me the base I keep. It's 4 plus 4. It's 2 to the power of 8. Great. Number 2 is a little bit different. We didn't encounter that in American problems, but maybe they think that we'll be confused with this because now it's an addition, it's a sum. But we understand that 2 to the power of 4 and 2 to the power of 4, it's the same object. Actually, we can perform factorization. We factor this common multiply being 2 to the power of 4. Then what is left from the first term is just 1. And what is left from the second term is exactly the same. It's this another one. So we perform the operation in the parentheses and get 2. We have 2 to the power of 4 and multiplied by 2. And now we know what to do. We know that we keep the base and we just add. We understand that here is actually 1, hidden 1 in the second term. And now we have 2 to the power of 5. This was something new from Russian school. Now, number 3. 2 to the power of n multiplied by 2 to the power of n. We know what to do. It's like the first one. We just write the same base, and we have actually, when we find this sum, we get this one. Actually, it's no wonder, because this one could be written as 2 to the power of n squared. And you can see that in this case we just multiply. We write 2 to the power of 2n. That's the same result, of course. And the last one is, again, it's like number 2, but in letters now. 2 to the power of n plus 2 to the power of n. I'll proceed exactly as I did in number 2. I just factor 2 to the power of n, and 1 comes from the first term, 1 comes from the second term. I perform this operation 1 plus 1. It's easy even for me this early on Sunday. And I get 2 to the power of n multiplied by 2, just 2 to the power of 1, or just 2. And now I understand that it's 2 to the power of n plus 1. That's it. That's my result. Well, as you can see, in Russian school, we have pretty the same exercises. And I think, to be honest, I think it's time for us to stop the recording. But where do I stop? Aha, here it is.